Hi there. Today we're going to start a new chapter on transformations, and this will be something kind of totally different from what we've been doing. And we're going to work with polygons, and we're going to transform them, which you can see here on this slide. It means that it's a mapping that changes a figure's position. That's how we transform it. Now, if it's a rigid transformation, it's going to stay the same shape and size. So if it's an equilateral triangle, it will stay that, but it's just going to move. Now, how we move it, we can vary, and we'll look at different ways. One of the other things about just the basics that we need to know going in, when we have some sort of a figure, a triangle, let's say, that's called the pre-image. And then after you move it, that's the image. That's the resulting figure. Usually our labeling on this, and the book and my notes and even Math Excel are all pretty consistent. The pre-image, the original image, is going to be in black, and it's just lettered typical E, F, G, H in this case. After you transform it, it maps to this new image. This is the pre-image. This is the resulting image. And now that E that used to be here, we call it E prime, and it has a little apostrophe thing there. And then this would map, F maps to F prime, G maps to G prime, and so forth. To say it maps to, we use that little arrow. All right, so just to have a good understanding of this, it says in the diagram, triangle NID maps to triangle SUP. Just like always when we talk about congruences or similarity, the letters, the order of the letters is important. N is going to map to the S, I maps to the U, D maps to the P. When you get these kind of triangles, sometimes it's a little bit deceiving about which letter went with which, because it's hard to tell. And so that's where we always trust the letters. So when it says, what are the images of angle I and point D? So for part A here, I'm going to say that angle I is going to map to, now you can look at the picture, but I'm going to trust up here in the letters. This I is going to map to U, the middle one. So I is my pre-image, maps to U. So it looks like it's a sort of it kind of rotates onto that. So then I would write angle I maps to angle U. For the second part, point D, again, trusting my letters, D is the third letter, so it's going to map to point P. All right, for part B, what are the pairs of corresponding sides? So we just, again, you can look, if the picture makes sense, you can trust the picture, or just go with the letters. NI corresponds to SU. Or I could go ID corresponds to UP. And then my last option, I could go N to D maps to S to P. So ND maps to SP. Those are the corresponding sides. Now, translations and reflections. To translate it, it's just going to move. It's going to slide is what we usually think of it. So it's just going to move. All the points from the pre-image are going to move the same direction and the same distance as one another. So whatever this direction and distance is, this is going to move the same direction and distance, same direction, distance. And that creates my image. It's a slide. All right, so when you look at this, the way that this is written, here is the notation. So this whole notes page here is on the notation. The capital T means that you're going to translate it. And then this right here, it's almost like an ordered pair, but you can see that it's more of like pointy arrows. And this tells you your horizontal movement. This tells you your vertical movement. So it's kind of like an X and a Y. So I'm going to translate 4 units right, 2 units down, this pre-image ABCD, and it's going to map to, and then we would call it A prime, B prime, C prime, D prime. Looking up here, you can see this is the pre-image, and let's just grab point B. it moved 1, 2, 3, 4 units right, 1, 2, 2 units down. So that's what B did, as did every other point, all mapped the same. All right, so let's try to do one ourselves. This says, what are the vertices of, after I do this translation, it says graph the image of PQR. All right, so here's my pre-image right here. And this right here says to translate it 2 units left, 5 units down. So I'm going to go over here and I'm going to take every one of these points and I'm going to go take R for instance, and I'm going to go 2 units right, or I'm sorry, 2 units left because it's negative, and then 5 units down because the negative, 1, 2, 3, 4, 5. And that spot right there is my new R, so I'm going to label that R prime. Now I'm going to do that with every point, so let's grab P. P goes 1, 2, left, 1, 2, 3, 4, 5. So there's P prime. And Q goes 1, 2, and then 1, 2, 3, 4, 5. There's my Q prime. And then I go ahead and draw the triangle. Now I will be grading these. Your homework on this is on a worksheet. And I'm going to grade it with like one of those overhead sheets. Like I've made the answer key and then I've like marked where that triangle is supposed to land, and then I'm going to lay it on top of yours and make sure yours lands in the right place. So you want to make sure that you're real particular about your point. Okay, let's try this going the other direction. They already have the image, the pre-image and the image. They have both. What they don't have is a rule, so I'm trying to figure out what did they just do to get from here to here. Well, it is a translation, but let's look and see if we can figure out how much it translated. So I'm just going to grab a point. It doesn't matter which one. I'm going to grab P. And it looks like P went 1, 2, 3, 4, 5, 6, 7, 8 units right, 1, 2 units down. Now I could check that with all of them, but they'll all do the exact same thing. 8 units right, 2 units down. So the way to write this will be with a capital T. And then down here kind of low, you're going to say what you did. And we said we went 8 units right, 2 units down. Of the original figure, which looks like it is PQRS. And then that's going to equal my image, P prime, Q prime, R prime, S prime. Okay, that's how our notation works. Okay, so this is a got it, which means you're supposed to try this one on your own. They are telling you where all these points moved to. So you can see in the pre-image from the picture, here are your ordered pairs, and they're telling you the new ordered pairs. Now, to be honest, you don't really need all of them. Just grab one of them. Grab M. Here's where M used to be. Here's where M is now. Go ahead and plot this point, and then write your translation rule based on how far it moved right, left, up, and down. Okay, I'm going to go ahead and have you pause the video. You go figure out the rule for this, and then come back when you got it. All right, here's my answer. Now, I had suggested that you look at M prime, but in all honesty, when I went and did it, I thought, well, gosh, that's off of my graph. So I went ahead and changed my plan to use L. I plotted L, and from that, I could tell that I went 7 units right, 1 unit down. So that's my translation rule. So the way you said, you're going to translate 7 units right, 1 unit down of this triangle LMN, and sometimes we'll put a triangle in front of it, probably should have there. And it's going to equal L prime, M prime, N prime. All right, let's keep moving. Sometimes we do multiple transformations, and so that's called the composition of transformations. If I do multiple translations, let's look and see how you can work through that. They have this bishop right here in this chess game. Here's the bishop, and he moved this way, and then he moved this way. So where is the bishop in relation to its original position prior to the 2 translations? All right, we're going to use the original position as 0, 0. So right here, we're going to assume is 0, 0. What just happened? Well, you kind of walk through it, and you can see you went, in that first move, it went 1, 2, 3, well, I should go right first, sorry. 1, 2, 3, 4 units right, 1, 2, 3, 4 units down. So you can see right here that this is the first translation. You took this ordered pair, we called it 0, 0, went 4 units right, 4 units down. Then you came back and you took that one and you went right 2, up 2. So you can see right here, took the new ordered pair that we had, took the new ordered pair, and translated it 2 units right, 2 units up. Ultimately, all you have to do is look at what your ordered pair is and add the translation to it. So that's what they're doing right here. They're taking the 4 and adding the 2. That's how we know we end up at 6. They're taking the 2 and adding it to the -4, which gets a -2. So from the original position, we are right 6, down 2. All right, so I'm going to skip over this next one, and let's just keep moving there. All right, because I'm going to move on to reflections then. We've done translations. It's just a slide. A reflection is something that flips over a line. So we're going to look at reflections across a line. In this case, you can see right here is my line of reflection. And when you reflect over a line, ultimately you draw like a perpendicular to that line of reflection. Drop that perpendicular, and then whatever that distance is, you go that distance again. And that becomes your new point. That reflection would fold over on top and land over here. This C would fold over and land on top of this C. But since A is actually on the line of reflection, okay, so let's try one. The notation that we have here, you have to have a capital R for a reflection, and it just tells you here what the reflection line is. In this case, now here's something that you're going to have to remember, and maybe jot this down some. We're going to be reflecting over horizontal and vertical lines, so we've got to go back and remember our Hooyvuks. Remember what that means, that if you have a y equals, that's a horizontal line. If you have an x equals, that's a vertical line. So right here, when I see this y equals 3, that's a horizontal line at 3. Okay? You can also reflect over other things. You might just reflect over the x-axis or the y-axis. There's other lines that it can be. All right, so let's look at this example here. So that's just kind of, this is kind of notes right here. Here's where I'm at. All right, let's do a reflection over the line x equals 1 of point P. And we'll call it P prime once we do it. And then they're going to ask me, what are the coordinates of P prime? All right, got it. So point P is at 3, 4. Let's go ahead and plot that. Over 3, up 4. There's my point P. And we're going to reflect over x equals -1. X equals is a vertical line. So it's going to be a vertical line at 1. I usually dash that line of reflection there. Okay, and now I'm going to fold my P over. So I look at how far is it from my line. That's 2 units. I'm going to go 2 units again. And it folds right over onto that spot, P prime. And then they want to know what those coordinates are. The coordinates of my P prime looks like I'm left 1, up 4. Those are your coordinates. Now that's just a point. We'll probably typically do more than reflect just a point. But we're going to have to... Let's try this one. It says graph points A, B, and C. Let's do that. A is -3, 4. So plot that point and let's label it A. B is at 0, 1. C is at 4, 2. So we have ourselves a triangle here. Now that's our pre-image. Now we're going to do this reflection right here. It says reflect over the y-axis. Got it? That triangle. All right, so here is my reflection. line, and so everything is going to get measured off of that. So A is currently 3 units from that line. I'm going to go another 3 units. So then this becomes, I don't know, I'm changing a lot of colors here. So that's my line. I'm going to call that A prime. C is 4 units. Now this is kind of weird because A was on the left of the line. It flips over to the right side. C is on the right side. It's going to flip over to the left side. 4 units. Okay, so that's C prime. And then look at B. B actually is on the line, so when you reflect it, it's not going to change. B is the same as B prime. So my reflection is going to be this yellow triangle here. You can see that it's going to start getting messy. Probably not necessary to draw those green lines that I did because that just makes it even messier. But make sure that you're counting how far off of the line it is and keeping it the same on both sides. I do want you to take your image, your resulting image here, and highlight it or use a red pen. Make your final answer stand out in some way. Okay, so this is the got it. This is your turn. It looks like you've got these points right here. They're the same points. It's the same triangle from earlier. Plot those points again. And this time you're going to reflect over the x-axis, and then let's see what you end up with. Go ahead and pause the video, plot your points, and then reflect it. All right, here's my answer. The black triangle there is my pre-image. It reflected over the red line, the x-axis, and my blue figure is the resulting image. All right, let's try another type of reflection. And this, not everything is based off of a coordinate plane. So if you look at this example, it's wanting me to write a reflection rule for triangle 2. So looking at these different triangles, 2 is a reflection of which of these other triangles, do you suppose? 4. It's 4, okay? So I know, and then the other part is which line did it reflect over? Okay, well I'm hoping you can see that 4 is reflecting over this K line here, and it's landing over here on this triangle 2. So to write that rule, we'd say triangle 2 is equal to a reflection, which is a capital R, and then down below, this little sub number, you have to write what it's reflecting over. I'm just going to write a little K, because that's the line it reflects over. And it's, what is it reflecting? It's reflecting triangle 4. So triangle 2 is a reflection over K of triangle 4. All right, see if you can do triangle 1 and write the rule for that. All right, you should have that it is a reflection over M of triangle 3. All right, last thing, just to kind of a recap over these reflections. It says, what are the coordinates of the reflection over the y-axis of point H? All right, looking at this, the y-axis is right here. I'm going to take point H and reflect it. Okay, that's 4 units there. Got to go 4 units here. There's my H prime. And that coordinate looks like it is -4, -3. So there's just that first part. And now, I didn't even do the whole triangle, but on your homework you'll do the whole triangle. What are the coordinates of a reflection over x equals 3 of point G? Okay, x equals Hooivux. X goes with V, vertical. It's a vertical line at 3. So now I'm working with blue here. And G is going to reflect over that vertical line. So it's 1 unit away, right here, and that coordinate is 4. Last one. Graph and label a reflection over y equals 4 of triangle FGH. Okay, let me get rid of all this extra stuff here. I'm going to reflect over y equals 4. Hoivux, y goes with h, a horizontal line at 4, right here. Now, this is a little bit tricky, which is why I'm doing this one. When you reflect this, it's going to end up off of my graph. Can you still work through it? Sure you can. Let's work with point F. Point F is right here, and it is 1, 2, 3, 4, 5 units off of the line. So that means I'm going to have to go 1, 2, 3, 4, 5 units above the line. Well, if you're at 4 and you go up 5 more, you're going to be up 9. So I know that that coordinate is going to be up 9. Now, as far as the horizontal movement, it didn't move horizontally at all, so the x value is going to stay -2. So f prime is -2, 9. Okay, why don't you go ahead and pause the video and finish out g prime and h prime for me. All right, here are my answers. And you can't really read mine very good, but on that H, I counted that to be 7 units right there. So that means it's got to be 7 units. That's what that says, 7 units off of that 4 line. So that's where I got my 11. Okay, that's all I've got for you. Hope this helps.